Okay, so now we're going to be looking at polynomial, and we're going to be kind of defining about finding the zeros, which are not going to be rational in this case, the extremas if they exist, also the local maximums and minimums if they exist, intervals, and the domain and range. So first I'm going to start off by talking about the degree of the polynomial and the leading term. So, okay, this is going to take 2 seconds. The leading coefficient is going to be 1 because there is always a 1. When there's nothing there, you can just assume there's a 1. We all know that, so we don't write it. Leading coefficient is 1. The degree is equal to 3. Because right here, x cubed, the degree of the polynomial is going to be equal to 3. So done. There we go. Now we're going to be finding the zeros and the multiplicities as well as the intercepts. That's a lot to take in, but it's going to be easy after I show you how easy it is. So we're going to be doing the cubic formula, not the quadratic formula, the cubic formula. Or we can use our graphing calculator, which will be much easier. So I already have inputted the function. So go ahead and do that. Enter, graph it, and it already has my graph as well, which may take a couple seconds to load on yours. But to find the zeros, what we're going to do is we're going to hit second. Okay, and then we're going to hit calc, which is going to be right here. If it focuses, probably won't. Go to zeros, which is number 2. And so if we look at the graph, we can get an idea of where the zeros are on the x-intercept. So we're going to go put our little pointer to the left of that, hit enter, and then also go to the right of that, hit enter, and hit enter one more time, and it's going to come up with an approximation. And this looks pretty accurate because it says that y equals 0 and x equals negative 1.39. So we know that's one of our zeros, is negative 1.39. Okay, and so we're gonna keep doing that for all the points on the x-intercept, and I've come up with them. I already have them calculated, but you basically do the same procedure, and you'll get the results. Zeros of negative 1.39, 0.227, and 3.16. Okay, those are the zeros of this particular polynomial. So now we're going to be doing the intercepts, and the intercepts are, you know, the x-intercepts are where y equals 0, and the y-intercepts are where x equals 0. So basically, we're just going to be taking the opposite sign of whatever our zeros are. And yeah, those will be, well actually, no, those are not, that would be getting the factors, but these are already zeros, so these are x-intercepts already. So negative 1.390. I guess you can just put them into points, that's a better way of explaining it. So here's the x-intercepts. 0.2270 and 3.160. So those are our x-intercepts. And now for the y-intercept. The y-intercept can just be found right there. The only number in this polynomial that isn't paired with a variable, it's the constant. So this is just going to be 0, 1. So that's y-intercept and the x-intercepts. And so that's good on that. And now we're going to be finding the multiplicities, which are just, okay, yeah, multiplicities. So I have a paper here which kind of explains what each of the multiplicities mean. Here's a multiplicity of 1, which is a straight line right through the x-intercept. Multiplicity of 2, where it touches it like a parabola. And a third, where it's like an S. So we're going to be looking at this, and we're going to say, okay, this one, this first point is going straight through it, so multiplicity equals 1. I'm just going to put M. The second point, if we look here, it looks like it's going straight through again, so multiplicity of 1, and the third point is doing the same, so all the multiplicities are going to be 1. If it were to be like an S-curve through there, then it would be different. It would be a multiplicity of 3, but it's not. So, yep, that took care of the multiplicities. Next is going to be finding the extremas. And the extremas are basically like the extreme points of this polynomial. Like what is the point that is the highest, what is the point that is the absolute lowest. Truth is about this polynomial is there is no extremas, and that's because there is it's basically like this graph looks like this, okay, and we have negative infinity and positive infinity, so there's no point. You can't say that's the extrema, no, because it keeps going. So we don't have a defined extrema. So it's going to be undefined for the extrema. Next is going to be finding like the local maximums and the local minimums. And this is also done through the graphing calculator. And I'll show you how to do that right now. We're going to press second again and calc, and then go down to minimum. And the local minimums are going to be found in just this part where there's actually some activity going on and not just the infinities, the positive infinity, the negative infinities. This is where the S is happening, is where your local minimum, the highest point of that. Can't remember if I clicked on, which one I clicked on. Alright, minimum. We're going to go ahead and put our little cursor to the left of the minimum, and then to the right of the minimum, and enter again. It's going to give us a point where it says it came up with 2, 7. Okay, and that's our local min. And we're going to do the same thing for the maximum, except we're going to hit second calc maximum. Okay, and then once you calculate that, I got max is negative 0.672.48 is the point. 2.48. So those are our local minimums and maximums that we just took care of. Easy. All through the calculator. Oh, I just erased the function. Great. Okay. Next we're going to be doing the domain and the range in interval notation. And since we already said, okay, there's no extremas, there's no limits to this graph because the end behaviors are limitless. Okay, there's negative infinity, there's positive infinity. So the range, which is going to tell us right to left, okay, that's going to be bracket negative, or parenthesis negative infinity, infinity. And I just realized that this is bottom to top, and the domain is the one that's right to left. Domain is like the x values, and range is the y values. That's how you can remember it easier. This one is also going to stay like that because we know that our graph is limitless both in the x direction and the y direction. It's going up limitlessly and it's going left and right limitlessly. So that's why the domain, you don't really have a limit on this graph. You don't have a defined area that you're focusing, or that the function goes through. So the last parts are going to be where we're going to write an interval that describes where the function is increasing and where the function is decreasing. So again, I'm just going to trace this graph, what it kind of looks like, just from looking at our graphing calculator, is it looks something like that. Okay, so basically what this question is asking is where is it increasing? So it's increasing from negative infinity here to this point, and then it increases again from this point to positive infinity. So basically, you're going to write in interval notation negative infinity. And the way you do this is the local max and that's the local min. Okay, so basically what you're going to write is negative infinity. That's where it starts, because we're describing the domain, which are the x values. So we're going to say negative infinity, and negative infinity, and then we're going to take it back up to that local min, or local maximum, which was at negative 0.67. Okay, and we're going to union that bracket, because it's a defined value. We're going to bracket that, or union that, with the local min, which was that 2, all the way up to positive infinity. Okay, and that's going to be increase. So decreasing is basically going to be from here. Okay, starting from here all the way down there. That's going to be our decreasing values. And that's going to be from that 0.67 value all the way down to this point, which is that 2. Okay. And that's pretty much all. Because, yep. Okay, so basically, to review what we've done, we have discussed what the degree of a polynomial, how to find that, how to find the leading term, how to find the zeros and the intercepts and the multiplicities, how to find the extremas. Well, not how to find the extremas, but we just found out that there are no extremas, and basically I kind of talked about what they are. And then we also talked about the local minimums, the local maximums, the domain and the range, and the interval notations, and where the graph increases and decreases, how you can write that in interval notation to kind of describe where the graph is, doing its thing.